Hello everyone, welcome to a new video in which we are going to continue our networking studies with the website known as Cloudflare. So without any further delay, let's begin. But first we have to initiate our Firefox instance, navigating to cloudflare.com. If you are unaware of why I am doing this, I must recommend you to watch the first video of this series. In that video, I have briefly talked about how and why I study networking, what is the current state of CCNA, should you do it or should not, what's CCNA worth it, etc. But the crux of that video is that you, in order to gain some knowledge, understanding of how a computer, or briefly, how a computer networks actually work, you have to be curious. Curiosity is the key. And to calm down our curiosity, we have to visit to the website, or you can say to tame our curiosity, you have to visit cloudflare.com. This website is collection of free and great resource regarding the how internet works. So where it was, uh, I'm sorry, once again, let me zoom out. Oh, where was the resource section? Resources. Okay, then we have to navigate to learning, then learning center, and starting from our DDoS attack. In the last video, we have already covered this DDoS attack section. So let me just go by through it, and you can certainly watch that. But one thing that I missed in the earlier video was to have a quiz from our beloved friend ChatGPT about the following section, that we got a hold of it or not. So in this video, we are going to do that. But before starting the quiz, we first have to finish every section of this DDoS. So we have already studied the first section, what is DDoS attack, and now it's time for what is DDoS botnet. And in order to enable to you see the content of the website, I'm toggling the reader mode on, and along with I'm also initiating my favorite note-taking application called VS Code. And first navigate to that folder. What was it? What was it? Cloudflare Hush. Yes, that was the folder. And yes, this is our readme file. Let me zoom it. And I'm very sure that the both things should be visible to you. Okay, now starting from this, what is botnet? While some while some malware such as ransomware will have a direct impact on the owner of the device, DDoS botnet malware can have different levels of visibility. Some malware is designed to take total control of device, while other designs to run silently as a background process while waiting silently for instruction, or bot herder. Okay, so the bot herder is the device that gives instruction to every other bot to attack on a particular device. Okay, self-propagating botnets recruit additional bots through variety of different channels. Pathway for infection include the exploitation of website vulnerabilities, Trojan horses, malware, cracking weak authentication to gain remote access, and once access has been obtained, all the method for infection result in the installation of malware on the target device, allowing remote control by the operator of botnet. Once the device is infected, it may attempt to self-propagate the botnet malware and recruiting other hardware devices in the surrounding network. Okay. While it's infeasible to point the exact number of bots in a particular botnet, estimation for total number of bots in a sophisticated botnet have ranged in size from a few thousand to a million. So what this is saying, that once our device get infected by any method, maybe the device has the physical access from the attacker. So once it infects a single device, then it will chain up and build a network of its own called the network of botnets. And on the advice of the attacker, it total set of botnet device attacks to a particular IP address or particular device. which leads to it downfall. And why are botnets created? The reasons for using a botnet range from activism to state-sponsored disruption. With many attacks carried out for profit, hiring botnet service online is relatively inexpensive, especially in relation to the amount of damage they can cause. The barrier to creating a botnet is also low enough to make it a lucrative business for some software developers, especially in geographic location where regulations and law enforcement are limited. This combination has led to proliferation. Would this word mean? Let me copy it, paste it. Proliferation. Proliferation. One second. I have to switch to my audio source to the headphones. Yes.
Proliferation.
Proliferation. The proliferation is the continuous development of cells in tissue formation. Okay. The continuous development. Okay. Of online services offering attack for hire. Okay. How is a botnet controlled? The core characteristic of a botnet is ability to receive updated instruction from the herder. Okay. This ability to communicate with each bot in the network allows the attacker to alternate attack vectors, change targeted IP addresses, terminate an attack, and other customized actions. Botnet designs vary, but the control structure can be broken down into two simple or general categories: the client server, and the other is peer-to-peer botnet model. Okay, so let me write that here. Botnet models. Net models. First is client server, and second is peer to. Actually, these also two refers to different models of networking. When a single device acts as a server as well as client, then it is called in peer to peer connection. Suppose, for example, if you airdrop something from your iPhone to another iPhone, then your phone is acting as a server and the other device, the other iPhone, is acting as a client. And if they airdropped you something, then the reverse thing happens. So in this scenario, the both a peer-to-peer connection has been established, and the both server and client roles are decided on the device depending on the situation who are sharing to which one. Okay, but in fixed or what is the opposite of dynamic? The fixed, the rigorous client server model, the server is always the server and has the files. The client does not become a server, it only receives and then performs some action. Okay, the client server model mimics the traditional remote workstation workflow where each individual machine connects to a centralized server in order to access information. In this model, once again, each bot will connect to a command and control center like a web domain or IRC channel in order to receive instruction. By using the centralized repositories to serve new command for the botnet, attacker simply needs to modify the source material that each botnet consumes from a command center in order to update instructions through the infected machine. This centralized server in control of botnet may be a device owned, operated by attacker, or it may be an infected device altogether. So a number of popular centralized botnet topology is the star network topology. And this is the revision of the topologies in network, that there is a single server and if there is a single infected device chaining to multiple other devices. The next is multi-server topology. So there is a hub of devices that are pre-chained together and are designated to infect the other devices. Then there is hierarchical network topology. Suppose this is the leader of the bot, an attacker, which is infecting multiple different devices, and then those devices are infecting other devices. In any of these client server model, each bot will be it will connect to a command center resource like a web domain or IRC channel. IRC channel, I think internet relay channel. Let me search for it. What does it mean? Mom, what does this mean? IRC channel. IRC is a text-based chat system for instant messaging. Okay, sounds like something archaic that we don't use today. It may be evolved to the WhatsApp or any messenger app that we use today, I guess. Never mind. Let's continue. By using this centralized repository to serve a new command for the botnet, an attacker simply needs to modify the source material that each botnet consumes from a command center in order to update instruction to the infected machine. Hand in hand with the simplicity of updating instruction to the botnet from a limited number of centralized sources is the vulnerability of those machines. Simplicity of updating instruction to botnet from a limited number of centralized sources is vulnerability of those machine. In order to remove a botnet with a centralized server, only the server needs to be disrupted. As a result of this vulnerability, the creator of botnet malware have evolved and moved toward a new model that is less susceptible to disruption via single or few points of failure. Okay, the evolution of the bad actor. The peer-to-peer botnet model. To circumvent the vulnerabilities of client-server model, botnets have recently been designed using components of a decentralized peer-to-peer file sharing, embedding the control of file structure. No. Embedding the control structure inside the botnet eliminates the single point of failure. Remember, guys, in network, as a network engineer, this is our task to eliminate the single point of failure. Even in the coding, even as a developer role, this is your task to use the try catch block statement in order to eliminate the single point of failure for a code. That a single thing ruins your entire program. If something is not working, it should print a message, not break the entire program. So this is called the single point of failure. And a peer-to-peer botnet model actually eliminates this, making mitigation effort more difficult. P2P bots can be both client and command centers working hand in hand with their neighboring nodes to propagate data. Okay. Peer-to-peer botnets maintain a list of trusted computers with which they give and receive communication and update their malware. By limiting the number of other machines the bot connects through, each bot is only exposed to adjacent devices, making it harder to track and more difficult to mitigate. Lacking a centralized command server makes a peer-to-peer botnet more vulnerable to control by someone other than the botnet creator. To protect against the loss of control, decentralized botnets are typically encrypted, so the access is limited. Okay. What was the CNC? Hmm. Command and Control Center. I think we should also follow a abbreviation list. Abbreviation. Okay. And let make this at the top. Okay. And everything else would be secondary. And abbreviation followed by first thing Command and Control Center CNC. Next. Yes. Yes. This was the definition or the example that won my heart. No one does their internet banking through the wireless CCTV camera. They put in the backyard to watch the bird feeder, but that does not mean that the device is incapable of making the necessary network request. And remember, guys, making a network request is inexpensive, but serving a network request with the help of server is quite expensive. So, the power of IoT device coupled with weak or poorly configured security creates an opening for the botnet malware to recruit new bots. So, the CCTV camera actually or may act as a bot for the botnet herder in order to make a DDoS attack to a banking website. Got it? And Yeah, an uptick in IoT device has resulted in a new landscape for DDoS attack, as many devices are poorly configured and vulnerable. If an IoT device vulnerability is hard coded into firmware updates and are more difficult to mitigate risk, IoT devices with the outdated firmware should be updated as default credentials commonly remain unchanged from the initial installation of the device. So this is saying that we have to change the default password or default name, even from such small things. For example, if this phone has a hotspot and if the password is default that the phone came with, it is highly likely to be intercepted or be easily connected by the bot. Many discount manufacturers of the hardware are not incentivized to make their devices more secure, and often this is true for the non-flagship phones because they don't often provide updates to it. Hence, making the vulnerability posed from the botnet malware to IoT devices remain an unsolved security risk. And how is an existing botnet disabled? By disable a botnet's control center. Botnets designed using command and control schema, okay, can be more easily disabled once the control center has been identified. Okay. So specifically we are talking about this client server model. Cutting off the head at the points of failure can take the whole botnet offline. As a result, system administrator and law enforcement official often focus on closing down the control center of these botnets. This process is more difficult if the command center operates in a country where law enforcement is less capable or willing to intervene. Okay. Eliminate infection on individual device. For example, yeah, for individual computers, strategies to regain control over the machine includes running antivirus software, reinstalling software from a safe backup, or starting over from a clean machine after reformatting the system. So you guys just have to format your machine on a periodic interval so any hidden malware get installed or deleted. I think I have already read this line somewhere here. Starting over from a clean machine after reformatting the system. For IoT devices, strategies may include flashing the firmware, running a factory reset, otherwise formatting the device. If these options are infeasible, other strategies may be available from the device manufacturer or a system administrator. And how can you protect devices from becoming part of the botnet? By creating secure passwords. But how? Simple as changing the administrative credentials to something that their default username and password, which makes creating a secure password make brute force attacking or brute force cracking difficult. What is brute force? Brute force is simply trying every possible combination. For example, trying everything that a person has. For example, if you know that the password is number and the number is of 3 digits, then you start from 000 and go up to 999. Hence, you tried every possible combination, and that is simply called brute force cracking. Brute force cracking. Next, creating a very secure password makes brute force cracking virtually impossible. For example, our device infected with the Mirai malware will scan IP address. Mirai is a form of malware, I don't know. Let's see what is it in a new tab. We will see that. And once a device responds to a ping request, the bot will attempt to log in to the found device with a preset list of default credentials. If the default password has been changed and a secure password has been implemented, the bot will give up and move on, looking for more vulnerable device. Next is only allow the trusted execution of the third party code. If you adopt the mobile phone model of software execution, only allowed application may run, granting more control to terminate software deemed as malicious, botnet included. Only an exploitation of this supervisor software, that is kernel, may result in exploitation of the device. This hinges on having a secure kernel in the first place, which most IoT devices do not have. and is more applicable to machines that are running third party software. And yes, this was the thing, periodic system wipe and restore. And this is the thing that I love to do the most. Restoring to a good known state after a set time will remove any gunk a system has collected, botnet software included. This strategy, when used as a preventive measure, ensures even silently running malware gets thrown out with the trash. Mind it. Next, implement good ingress and egress filtering practice. So, ingress is the incoming and egress is the outgoing. Uh, it may be outgoing filter, outgoing traffic, anything. Other than the most advanced strategies include filtering practices at network routers and firewalls. A principle of secure network design is layering. You have the least restriction around the publicly accessible resources while continually beefing up the security for things you deem sensitive. Deem means I think you feel sensitive. Additionally, anything that crosses these boundaries has to be scrutinized. Network traffic, USB devices, etc. Quality filtering practices increase the likelihood that the DDoS malware and their methods of propagation, the communication will be caught before entering or leaving the network. And this is the advertisement for the Cloudflare that if you are under attack, there are steps that you can get out and from the under pressure. If you are on Cloudflare, you can follow these steps. So we are not on Cloudflare, so we will move to next topic called common DDoS attacks. Okay, do have a list of here common DDoS attacks, and I think we should copy this list here. Common DDoS. First is application cryptocurrency. Next is DNS amplification. Next is L3 attack, layer 3 attacks, low and low attack. Next is meme cached DDoS, meme cache. And next is NTP amplification, network time protocol amplification. Then there is ransom DDoS attack, ransom. Next is SSDP. Okay. Next is ping of death. And finally, Smurf. Let's dive into every type of attack, starting with application layer attack. Application layer attacks, also known as L7 attacks. Okay. So if I write here L7, yes, refers to a type of malicious behavior designed to target the top layer in the OSI model, where the common internet requests such as HTTP GET, POST occurs. These layer 7 attacks, in contrast to network layer attacks such as DNS amplification, are particularly effective due to their consumption of server resources in addition to network resources. Okay. These layer 7 attacks, in contrast to other network layer attacks, for example DNS amplification, are particularly effective due to their consumption of server resources in addition to network resources. And how application layer attack works, the underlying effectiveness of the most data comes from the disparity between the amount of resources it takes to launch an attack relative to the amount of resources it takes to absorb or mitigate. While this is still the case with the L7, the efficiency of affecting both the targeted server and network requires less total bandwidth to achieve the same disruptive effect. An application layer attack create more damage with less total bandwidth. So it does mean that in order to initiate an attack, it is very easy, but in order to mitigate it, it is very hard. And the server does take a toll when multiple resources, multiple layer 7, suppose HTTP. If I refresh this page repeatedly, uh, as the Cloudflare is a very big or large server with the capacity of handling multiple requests, but if it was a small server, then if I press the F5 button or refresh the page continuously, it may take a toll to server, and it becomes sluggish, and it may not be able to serve the other parties on the internet. So this is what this article is saying. To explore why this is the case, let's take a look at the difference in relative resource consumption. So we are going to look some resource consumption. For example, when a user sends a request logging into an online account such as Gmail account, the amount of data and resources the user computer must utilize are minimal and disproportionate to the amount of resource consumed in the process of checking login credentials, loading the relevant user data from a database, and sending back a response containing the request web page. For example, just try to understand that attacker only have to enter some random username and some random password, but this server has to check its database whether this a username exists or not, whether the password is incorrect or correct. And if the password is correct, then they have to share the complete information regarding that user to the client. And this is how much work a server do. Even in the absence of a login, many times a server receiving a request from a client must make database query or other API calls in order to produce a web page. When this disparity is magnified as a result of many devices targeting a single web property, like during a botnet attack, the effect can overwhelm the targeted server. So the server may take a toll, resulting in denial of service or legitimate traffic. And then the server will not be able to simply follow the request of the normal legitimate user. In many cases, simply targeting an API with a L7 attack is enough to take this service offline. Okay. And why it is difficult to stop application layer DDoS attack? Because the distinction between the genuine person accessing the network and a botnet performing a HTTP flood is very difficult to differentiate. And because each bot in a botnet makes seemingly legitimate network requests, the traffic is not spoofed and may appear normal in origin. And this layer requires an adaptive strategy, including the ability to limit traffic based on the particular set of rules, which may fluctuate regularly. Tools such as a properly configured WAP, web application firewall. Let me write it. Or no, I already know the meaning behind, but you guys, you may copy these notes from the GitHub page that I will be soon uploading it to, and make your own notes on the top of it, or make a fork of this note, and put your desired content in that. Okay. Only then you are able to actually recall these stuffs. Next, so can mitigate the amount of bogus traffic that is passed on an origin server, greatly diminishing the impact of the DDoS attempt. So what is an origin server? The origin server is the actual device where the original content is stored. So if I'm making a request to the Cloudflare, the origin server is the server that Cloudflare maintains. And from on that website, on that server, basically server is a computer. So on that computer, the files for this, the content that I'm reading here is actually stored there. So greatly it diminishes the impact of the DDoS attempt. Okay. While other attacks such as SYN flood or reflection attacks such as NTP amplification, strategies can be used to drop the traffic fairly efficiently, provided the network itself has not the bandwidth to receive them. Unfortunately, most network cannot receive a 300 Gbps amplification attacks, and even fewer networks can properly route and serve the volume of application requests L7 can generate. Okay. And what tactics to help minimize, yeah, mitigate the application layer attacks? One method is to implement a challenge to the device making the network request in order to test whether or not it is a bot. This is done through a test which is called CAPTCHA test, commonly found in the creating an online account. By giving a requirement such as a JavaScript computational challenge, may attack can be mitigated. Okay. So if you're not able to submit the correct captcha, then you cannot able to bypass or reach the server in order to make the computations on a server occurs. So I think that the captcha test must be or should be client side rendered. I think, let's see, let's search for it. Let's summon our beloved friend ChatGPT, zooming it so you guys can see it clearly. R captcha, captcha client side rendered. If not, then how can it prevent L7 layer 7 attacks? Let's see. CAPTCHAs are often rendered on the client side, but their effectiveness in preventing layer 7 attacks, especially more sophisticated ones, comes from a combination of server side check and client side rendering. Okay. Okay. After the user interacts with CAPTCHA, the browser sends the response to the server for validation. Server verifies whether the response is correct or incorrect, sending it to the CAPTCHA provider service. If the CAPTCHA provider service verify that the response is legitimate, the server proceeds with the request. And if the response is invalid, the server rejects the request. Okay. Okay. Since bots cannot easily solve CAPTCHA challenges, such as identifying objects, they prevent automated script from successfully interacting with the website. Okay, good. And this is how we finished our application layer attacks. Next is cryptocurrency attack. Let's read that. A cryptocurrency is a form of digital currency that has two key differences which distinguish it from the traditional money. First of all, cryptocurrency is not tied or backed by any government, making it a truly international form of currency. And second, cryptocurrency is always decentralized. So those who don't know now know that what the cryptocurrency is actually is. And difference between centralized and decentralized currency. Traditional money is centralized. If someone with has US dollars put their bank in a brick and mortar bank, then the bank will be responsible for keeping track of that currency. The owner of the money will have to go back to the bank to their currency out. Similarly, if the person wants to keep their dollar into an online bank, that online bank will be keep a record of the amount of the money in the person's account in a central server. That bank's central server is the authoritative source of the information for the person's account. In both these cases, the currency is centralized, meaning it's kept track of in one place. With cryptocurrencies, the information about the amount of the currency each investor owns is owned and stored often thousand different computers known as nodes. The information on these nodes are publicly accessible and there is no single central authority responsible for keeping track of these accounts. This means whenever a transaction happens, every node has to be updated simultaneously, ensuring that the ledgers in all nodes remain in sync. And it is very important that these nodes remain in sync because otherwise the currency would be invalidated by the possibility that someone spends the same money twice before all the ledgers have a chance to update. And this is known as double spending. The double spending of cryptocurrencies is prevented by the process called blockchain. And here we come. The blockchain is a technological breakthrough that makes the cryptocurrency possible. Our full technical explanation of blockchain is beyond the scope of this article, but important key takeaways is that blockchain requires mining. And what is mining? The it is like hell. We are studying a new topic back to back. We were studying the DDoS attack, then we have a cryptocurrency attack, and in the cryptocurrency attack, we are learning about cryptocurrency. Then we have to learn about blockchain, and then we have to learn about mining. And the mining of cryptocurrency is a process where a computer spends time solving a highly complex math problem, and once that problem is solved, a set of cryptocurrency transactions get added to the queue of similar set of transactions, which will broadcast to all the nodes, updating their ledger. In order to encourage mining, computers which solve these complex math problems are rewarded for doing so with newly minted coins for the currency that they are mining. And this is how new cryptocurrency comes into circulation. Okay, so if I engage my computer into cryptocurrency mining, then my computer will be rewarded with some of the coins that it mined. Okay, and why are cryptocurrencies being DDoSed? And we are back from a circle, starting from there, here, there, and finally back to why it is DDoSed. Like the most high visibility business, coin exchanges have targeted with the DDoS attack. With this surge in interest and the resulting increase in the traffic around cryptocurrencies, the door has opened for the bad actors to attempt to disrupt cryptocurrency resources, denying crypto coin user access. A distributed denial of service attack is one of the primary method of disruption in the modern internet. By overloading a target with bogus traffic, a bad actor is able to render a website or service unavailable. The popularity and importance of cryptocurrencies make them a prime target for the attack. We have been analyzing some of the DDoS attack hitting the many coin exchanges on our network in order to gauge any discernible patterns of interest. The most prominent volume of the DDoS attack originated from the SSDP amplification attack, the NTP amplification attack, and the application layer attack. We do have to study the SSDP amplification. Let me write amplification as well. And next, one popular coin exchange service has been flagged for 76 application layer DDoS attacks over about a year. Though it's worth noting that the incredible surge in traffic may create false positive, where normal traffic may show some signs of being attacked. Regardless, it is clear that the big Bitcoin exchange have become the prime targets for DDoS attack. Here's a graph showing the number of potential application layer attacks targeting the popular cryptocurrency web properties through mid-December 2027. 2017. Okay. So here is the search. Of particular interest in the huge spike in the attacks around November 11. During this time, a number of blockchain currencies provider sites appear to have targeted. Luckily, our DDoS mitigation software and infrastructure were able to prevent service disruption. Okay. Even in the best of circumstances, many of the websites and applications related to Bitcoin and other cryptocurrencies do not have resources to deal with massive surge in traffic. And such increases can occur during a DDoS attack or during high level of normal traffic, resulting in temporary outage and denial of service. So let me first make an hierarchy for the same. So what we are studying? We are studying about cryptocurrency. Double hashtag cryptocurrency. Then triple hash. Then we learnt about something called blockchain. Then we 4 times hash. Then we learnt about cryptocurrency mining or simply mining. And after mining, we are back to our DDoS. Okay, that's all. And time to next topic. To next topic, which is DNS amplification. The most simple, most common, and the most uh, tough thing or tough attack. Control Alt and R. This is what is an DNS amplification. The DNS amplification is a reflection based volumetric distributed denial of service attack, in which attacker leverage the functionality of open DNS resolver in order to overwhelm a target server or network with an amplified amount of traffic, rendering the server and its surrounding the infrastructure inaccessible. All amplification attacks exploit a disparity in bandwidth consumption between an attacker and the targeted web resource. When the disparity in cost is magnified across many requests, the resulting volume of the traffic can disrupt network infrastructure. By sending small queries that result in large responses, the malicious user is able to get more from less. By multiplying this magnification, by having each bot in a botnet making similar requests, the attacker is both obfuscated from detecting and reaping the benefits of greatly increased attack traffic. A single bot in a DNS amplification attack can be thought of in context of a malicious teenager calling a restaurant and I will have one of everything. Please call me back and tell me my whole order. And when the restaurant asks for a callback number, the number given is the targeted victim's phone number. Just quite like the courier boy example that I've given in the previous video. That you order something, but on the address of the victim, and you have you chosen to pay cash on delivery. So the delivery boy visits the victim and asks for the payment for the resources that you ordered, and that is the whole thing. As a result, for each bot making requests to open DNS resolvers with a spoof IP address, which has been changed to real source IP address of the targeted victim, and the target then receives a response from DNS resolver in order to create a large volume of traffic. The attacker structures the request in a way that generates large response from DNS resolver as possible, and as a result, the target receives the amplification of the attacker's initial traffic, and their network becomes clogged with the spurious traffic, causing denial of service. The DNS amplification can be broken into 4 steps. An attacker uses a compromised endpoint to send UDP packets with a spoofed IP address to a DNS recursor. The spoofed address on a packet points to the real IP address of the victim. Okay? Each one of the UDP packets make a request to a DNS resolver, often passing an argument with any in order to receive the largest response available. Okay. And after receiving the request, the DNS resolver, which is trying to be helpful by responding, sends a large response to the spoofed IP address. Okay. And finally, the IP address for the target receives the response, and surrounding network infrastructure becomes overwhelmed with the deluge of traffic, resulting in the denial of service. So let me once again, I just want to make it clear to you guys because these things actually excites me. So let me have my pen, and I'm going with color red here. Okay. So what is this? That this is our target victim. Okay, and this is the attacker. The attacker says that I am target victim. I am the target victim. Okay, and I want to visit. I want to visit this site, this website. Okay. Then DNS resolver will think that he needs to visit this thing or he needs something. So I have to send it back. So DNS resolver just want to help it, but instead of sending this, because this is an spoofed, it just makes a request and then cut off to the network. Then the request actually flows to this target victim, and this target victim is overwhelmed. And this is how, simply how this type of attack works. Next, while a few requests is not enough to take the network down infrastructure, when the sequence is multiplied across the multiple requests and DNS resolver, the amplification of the data and target receives can be substantial. And how is DNS amplification actually mitigated? For an individual or a company running a website or a service, mitigation options are limited. This comes from a fact that the individual server, while it may be to the target, it is not where the main effect of a volumetric attack is felt. With the high amount in traffic generated, the infrastructure surrounding the server feels impact. The internet service ISP or other upstream infrastructure provider may not able to handle the incoming traffic without becoming overwhelmed. As a result, ISP may black hole all traffics to the target victim and protecting itself from taking the site offline. Mitigating strategies abide from once again I want to introduce a new party in this. So let me open what my uh, annotator first. So here it is. I have to now make the complete diagram by myself. So listen guys, so here is an attacker. Let me make a drawing of the person. Y- this guy A stands for attacker, and this is the attack E, the person on which the attack is going to happen. One second, I may be protruding this part. So let me draw it above. Where is the razor? I don't have any razor. No problem. So this is an attackee B. On this guy, the attacks actually going to happen. And here is our third party called ISP, the internet service provider. For example, Reliance Jio, Airtel. If you're in India, then these are the ISPs. Orange Mobile, or I don't know, T-Mobile, etc. are the Vodafones, etc. are the foreign or international ISP. So this is the ISP, and this guy has a server. It maintains a server. This server actually connects to ISP in order to access the global internet. And this is our internet. Article, this thing is quite messed up, but relax, I will certainly trying to explain. And this ISP allows everything to be carried on global internet. And and there is a DNS server on the internet. Okay, which is being helpful. So A, the attacker uses his computer in order to send some queries to the DNS, and then DNS actually spans the internet and sends some request to ISP. It is not likely that this server fails. It may fail, but in the most cases, actually what ISP does, it route all the traffic to the black hole, and that's how the traffic got diverted from this to that, and this server is become offline, which is what the attacker always dreamt of. And this was quite fun. I should use this screen instead of that, but I will from now. Okay, and finally, reduce the total number of open DNS resolver. An essential component of the DNS amplification attack is access to open DNS resolver. By having poorly configured DNS resolver exposed to the internet, all an attacker needs to do is to utilize a DNS resolver to discover it. Ideally, the DNS resolver should only provide their services to devices that originated within trusted domain. In the case of a reflection based attack, the OpenDNS resolver will respond to all queries from anywhere on the internet, allowing the potential for exploitation. Restricting a DNS resolver so that it only responds to queries from trusted sources makes the server a poor vehicle for any type of amplification attack. Okay. Now I am feeling some kind of what to say. One second. What was it? What was it? Insecurity that actually where the DNS is stored on the internet. So is there a server just like an actual Google data center? Is there an actual DNS data center? Let's ask the chat GPT. Let me reload it so it clears our previous conversation. Yes. Is there a DNS data center out there that stores all the IP addresses linked to respective name URL? Let's see what the GPT has to say. Please say it. There is not a single DNS data center or a services that store all IP addresses linked to their respective URL globally because the internet is vast and highly distributed. The DNS server do play a crucial role in mapping. Okay. So when you type a URL into a browser, a DNS resolver queries authoritative DNS server to translate, and we have multiple layers in the process. We have the root DNS server, TLD server, authoritative DNS server. Okay, and the root DNS server is these helps to direct queries to the correct top level domain. And then there is this handle queries for the specific domain suffixes like .com, .org, etc. And then these hold the actual record for the domain, the authoritative DNS server. Okay. And as a result, each authoritative DNS server has a subset of domain to IP mapping that it manages. The mapping typically limited to a specific domain under its responsibility. And then we have DNS caching and propagation. Since DNS records are cached at various points, like your ISP's DNS server on your device, not every DNS resolver will query the authoritative server for each domain all time. Therefore, if an authoritative server stores the mapping of domain to IP, results may persist for a while, including reducing the need for repeated lookups. And some organization and services aggregates DNS data, making it publicly available, but they do not contain all DNS record for internet. Instead, they offer partial data like subset of domain to IP mapping, often focused on particular geographic region, set of domains or time frame. For example, Google Public DNS, our Cloudflare's DNS, these services provide DNS lookup capabilities and may cache large portion of DNS record, but they do not store a comprehensive global mapping of all domains. And then we have some data providers, for example, domain tools, security trials, and Cisco Umbrella, formerly OpenDNS, may aggregate large DNS dataset for the purpose such as cybersecurity, research, and domain intelligence. And we do have a reverse DNS lookup, which is the opposite of typical DNS lookup. It involves finding a domain name based on the IP address, while reverse exists for some IP addresses, especially those owned by major companies used for web hosting. It is not comprehensive or exhaustive database of every IP to domain mapping. And when then we have internet registries, the global infrastructure of IP addresses allocation. Okay. So the crux of this, that is DNS is inherently decentralized with records distributed across a variety of authoritative servers. However, certain services aggregates large portion of DNS data for research, security, and analytics purpose. But these are the partial data sets and not comprehensive global mappings. So that is the DNS, and we still do have time, so we can certainly cover another topic. And yes, Mirai botnet. And while we are here, let's study about Mirai botnet as well. A Mirai is a malware that infects smart devices running on ARC processor, turning them into a network of remotely controlled botnets or zombies. This network of bots called botnet and often used to launch DDoS attacks. Malwares, short for malicious software, is an umbrella term that includes computer worms, trojans, horses, rootkits, and spyware. In September 2016, the authors of Mirai malware launched a DDoS attack on the website of well-known security expert. A week later, they released the source code into the world. Possibly in an attempt to hide the origins of attack, the code was quickly replicated by other cyber criminals and is believed to be behind the massive attack that brought down the domain registration services provider DYN in October 2016. One second, I have to reread there because actually it blows my mind. Mirai is a malware that infects smart devices that run on ARC processor. And what is this ARC processor? Let's see. ARC processor. Copying it, pasting it. ARC embedded system processors are family of 32-bit to 64-bit reduced instruction set. Okay. Central processing unit designed for ARC International. ARC processors are configurable, extensible for wide use of on-chip devices, including storage, digital, home, mobile, automotive, and Internet of Things application. Okay. So ARC stands for Argonaut Risk Core. Let's copy it, paste it here. Next. Yes. To remote this network of bots called botnet and often used to launch DDoS attack. Malware, in short of malicious software, is an umbrella term that includes computer worms, viruses, Trojan horse, rootkits, and spyware. In September 2016, the author of Mirai malware launched a DDoS attack on the website of a well-known security expert. Okay. So Mirai malware was launched a DDoS attack on the website of a well-known security expert. A week later, they released the source code into the world, possibly in an attempt to hide the origins of the attack. And this code was quickly replicated by other cyber criminals and believed to behind the massive attack that brought down the domain registration and service provider. What does it mean? Okay, let me try to explain it. So, in this case, this is our attacker. Okay, this is A. A stands for attacker. And this is our B. B stands for victim here. Okay. So, and we have a malware called Mirai. What was it? Mirai. Mirai. Okay. Mirai. So, we have Mirai. A attacked B using Mirai malware. Okay. And after that, they opened the opened the source code of Mirai to the world, so they cannot be get tracked. And now the third parties, for example C and D, can use the Mirai source code in order to perform some attacks on some extra parties. For example, maybe B again, or may not be B again. So it can attack E, F, G by using the same source code of Mirai. And it is quite funny because E released the source code of Mirai in order to making him untrackable. I don't know how they did this, but the pure intention behind releasing this source code was to become the untrackable. But now the same source code is used by some other parties in order to perform attacks on different parties altogether. And this is the example of pure chaos. And how does the Mirai work? Mirai scans the internet for IoT devices that run on ARC processor. This processor runs a stripped down version of the Linux operating system. And if the default username and password combination is not changed, Mirai is able to log into device, affect it, infect it. IoT, short for Internet of Things, is just a fancy term for smart devices that can connect to a internet. These devices can be baby monitor, vehicles, network routers, agriculture device, medical device, environmental monitoring device, etc., etc., etc. Mirai botnet employed 100,000 hijacked IoT devices to bring down DYN. And who were the creators of Mirai botnet? 21-year-old Paras Jha and 21-year Joe Shah White co-founded the ProTaf Solution, company offering mitigation services for DDoS attack. Theirs was a classic case of racketeering. Their business offered DDoS mitigation services to very organization their malware attack. And what does it mean? Racketeering. Let's search it. Racketeering is a type of organized crime in which perpetrators are coercive, fraudulent, extortionary, and otherwise illegally coordinated scheme or operations to repeatedly or consistently collect profit. Once again, a racketeering organized crime in which the perpetrators set up a coercive, fraudulent, extortionary, or otherwise illegal coordinated scheme or operation to repeatedly or consistently collect profit. Okay, okay. So selling basically selling medicine for the disease that he himself curated, I guess. So why does the Mirai malware remain dangerous? The Mirai is mutating. Okay, though its original creator have been caught, their source code lives on, and it has given birth to variant such as Okiru, Satori, Masuta, and Pure Masuta. The Pure Masuta, for example, is able to weaponize the HNAP bug in D-Link devices. The OMG strain, on the other hand, transform IoT devices into proxies that allow cyber criminals to remain anonymous. There is also a recently discovered and powerful botnet, variously nicknamed IoT Rooper and Reaper, which is able to compromise IoT devices at a much faster rate than Mirai. The Reaper is able to target the large number of device makers and has far greater control over its bots. And what are the other and different various botnet models? Centralized botnet, tired CNC, decentralized botnets. Okay, let's read it one by one. So where we were? Yes. If you think of a botnet as a theoretical play, the CNC, command and control server, also known as C2 server, is its director. The actors in the play are the various bots that have been compromised by the malware infection and made part of the botnet. When the malware infects a device, the botnet send out the timed signals to inform that the CNC and that it now exists. This connection session is kept open till the CNC is ready to command the bot to do its bidding, which can include sending out spam, password cracking, DDoS attack, etc. In this centralized botnet, the CNC is able to convey command directly to the bots. However, when CSC is also a single point of failure. So we are back to the client server model and the peer to peer model. So currently we are learning about how the client server model in which there is a centralized botnet which leads to a single point failure. And we have tiered CNC. Tiered. I think it should be pronounced tiered. Let's see its pronunciation as well.
Tiered.
Tiered. Exactly. Tiered CNC. Botnet controls may be organized in multiple tiers. With multiple CNC, group of dedicated server may be designated for a specific purpose. For example, to organize the bots into subgroup to deliver designated content and so on. This makes the botnet harder to take down. Okay. And now we have the decentralized botnet. Okay, so with client server model, we do have uh, tiered models, tiered C and C. Okay, then we have peer to peer or called the decentralized. The peer-to-peer botnets are the next generation of botnets that rather to communicate with a client server, a P2P bots act as both command server and the client which receives a command. This avoids the single point of failure to inherit the centralized botnets. Because P2P botnets operate without a CNC, they are harder to shut down. Frozen.pcom and StormNet are the example of malware behind the P2P botnet. How does a malware turn IoT device into bots? In general, email phishing is a demonstratively effective way of infecting the computer. The victim is tricked into either clicking a link and points to a malicious website or downloading infected attachment. Many times the malicious code is written in a way such that a common antivirus is not able to detect it. In case of Mirai, the user does not need to go beyond leaving the default username and password on a newly installed device unchanged. And what is the connection between Mirai and click fraud? PPC, pay per click, or known as cost per click, is a form of online advertisement in which company pays a website to host their advertisement. The payment depends on how many site visitors clicked on that ad. When cost per click data is fraudulently manipulated, it is known as click fraud. And this has done by having people manually click on ad by use of automated software or with bots. Through this process, fraudulent profits can be generated for the website at the expense of company placing those ads. And the original authors of Mirai were convinced for leasing their botnets out for the DDoS attack and click fraud. And why are botnets dangerous? Because they have the potential to impact virtually every aspect of person life, whether they use IoT device or not, or even the internet. The botnets can attack ISP, attack your internet service provider, resulting in denial of service that we have just exemplified that how the ISP routes to particular traffic. For example, just like this git logo, actual traffic being routed to the black hole, and because of black hole, the legitimate traffic's also routed to black hole and leads to the offline, leading to an offline website. And it may send spam email, launch DDoS attacks, and bring down the website and APIs, perform click fraud, solve weak captcha challenge on website in order to intimate human behavior during logins. Okay, so now we are studying how we can prevent it. Okay, hold companies to ransom with threats of DDoS. Okay, and why is the botnet proliferation so hard to contain? There are many reasons why it is so difficult to stop the proliferation of the botnet. IoT device owner. There is no cost of interruption in service, so there is no incentive to secure the smart device. Infected device may be cleaned out with a reboot, but since the scanning for potential bots happen at the constant rate, it is possible for them to reinfect within minutes of the reboot. This means user have to change the default password immediately after reboot, or they must prevent the device from accessing the internet until they can reset the firmware and change the password offline. Most device owners have neither the know-how nor the motivation to do so. The increased traffic on their network from the infected device typically does not compare to the traffic that the media streaming generates, so it is not much incentive to care. There is little incentive for device manufacturer to invest in security of low cost device. Holding them liable for attacks might be one of the way of forcing change. Though this might not work in regions with lax informant. I think What is lax enforcement? I think it may be typo, but it might be something. Let me Google it. Lax laws. Let us ask the GPT. What does it mean? Lax enforcement of DNS security. Lax enforcement of IP address ownership. Okay. Lax enforcement. Okay. I got it. The laws related to some networking stuff called the lax laws. Okay. Ignoring device security come at a great peril. Mirai, for example, is able to dispense antivirus software, which makes reduction a challenge. And the magnitude. With over 1.5 billion ARC processor based device flooding the market each year, the sheer number of devices that can be conscripted into powerful botnets, meaning that these variants simply have grown in possible impact. Simplicity. Ready to go botnet kits are evaluate the need of tech savvy. For example, for just $15 to $20, a botnet can be leased for an entire month. Okay. Global IoT security standards. There is no global entity to define and enforce IoT security standards. While the security patches are available for some device, user might not have the skill or incentive to update. Many manufacturers of the low-end device don't offer any kind of maintenance at all. For ones that do, it is often not the long term. So there is also no way to decommission device once the updates are no longer maintained, making them indefinitely unsecure. And finally, where we were? Yes, global law enforcement. The difficulty in tracking down and prosecuting the botnet creator, making the containment of the botnet proliferation difficult. There is no global Interpol equivalent for cybercrime. There is no global Interpol equivalent international criminal police organization for cybercrime. With corresponding investigative skills, law enforcement across the globe is commonly has not been able to keep up with cyber criminals when it comes to latest technology. Many botnets now employ a DNS technique called fast flux in order to hide the domains they use to download malware or to host phishing site. This makes them extremely hard to track. Now I have to study about fast flux. I have to write these fast flux. And it does botnet infection degrade performance for IoT device? It might. Every once in a while, infected device might perform sluggishly, but they mostly work as intended. Owner have no great motivation to find ways to clear out the infection. And addendum. What does it mean? Addendum. Addendum. Something added to or add to be added back, especially as a supplement to a book.
Addendum.
A thing has to be added. An appendix or addition. Okay. A legislation on the desk of California Governor Jerry Brown requires that an IoT device have reasonable security features appropriate to the nature and function of device. This would come into effect in January 2020, and this legislation is so important. The lucrative California makes it impossible for companies to ignore. They want to sell in California, they need to improve security in their devices, and this will definitely benefit all the states. Just crossing the finger that this kind of restrictions or restrictions come to India as well. And so we have studied the DNS amplification till now. So I have to yes as per last video. Okay. Now the time is around 7:32 p.m. and after a few more hours and few more minutes, I have to go to office. Hence, I am ending this and finishing this screen, wrapping up right now. See you guys in the next video, and be sure that we will be doing some quizzes on this complete DDoS scenario. We will have quiz to the all web pages, starting from the first to the last. and we will complete the else thing in the next one. Okay, guys. Thank you for having with me. Thank you for spending time with me, and see you on the next one.